The domain is all real numbers. Our range, how far down this graph goes, it goes forever down. Again, make sure you put the least first. My x-intercept is going to be 2, 0. My y-intercept is 0, 1. As I go left to right, the x values that cause this graph to go up are none because this graph never increases. It's always decreasing. And all real numbers cause this graph to go down. My end behavior, as x approaches negative infinity, f of x approaches positive infinity. As I go left, my graph is going up. Then we have, as x approaches positive infinity, f of x approaches negative infinity. So as I go toward the right, my graph is going down. Here we have another quadratic, a parabola. Our domain is all real numbers. We can use any x value, but range, we're going to have a restriction here. And I'm going to put this vertex. And so it's -6, 7, 8, and 9. So this is -9. And so the least value it can be is -9, and it can be -9. So we use a bracket. And then it extends forever in the positive direction. We have 2 x-intercepts, and that's going to be -2, 0. And we have 4, 0. Our y-intercept is going to be 0, -8. We're going to have that axis of symmetry that's going to help us. So let's say x equals 1. So the 1, when x is 1, our graph changes from going down to going up. So the increasing part is going to start here at 1. And so from 1 to positive infinity, this graph increases. The part that causes it to go down is from negative infinity to the 1. Our end behavior, as x approaches negative infinity, f of x approaches positive infinity. As x approaches positive infinity, f of x approaches positive infinity. So when you have a quadratic, your ends are going to be going in the same direction. So as I go left, the graph goes up. As I go right, the graph goes up. Number 3, our domain is all real numbers. Our range, we can go forever down, and the outputs go forever up. Our x-intercept is -1, 0, and we have 2, 0. Our y-intercept is going to be 0, -2, and it increases. Let's draw these lines for ourselves. So this is x equals -1, and then this change is going to be x equals 1. So what causes this graph to go up? So it goes up from negative infinity to 1. Again, increasing and decreasing is all about the x values. The x values cause it to increase or decrease. So from negative infinity up to the -1, it goes up, as well as from 1 to positive infinity. And the interval that causes it to go down is from -1 to +1, it decreases. As x goes left, f of x goes down. As x goes right, f of x goes up. Number 4, we have our asymptote right here. This is y equals -4. Our domain is all real numbers. Our range can go down to the -4, but not included. Our x-intercept is 0. Whoops, excuse me. Let's write this right. Our x-intercept is 2, 0. Our y-intercept is 0, -3. Increasing, this graph is increasing all the way across, so all real numbers cause it to increase, and it's not decreasing anywhere. As x approaches negative infinity, as we go left, that's a little sloppy, sorry, f of x approaches the asymptote of -4. As x approaches positive infinity, f of x approaches positive infinity. Okay, here we have a different graph. Our domain, still we can go forever left. We have these arrows, and forever right. The range, however, it goes down -1, -2, -3, -4. So at -4, and it is included, and then it goes forever up. Again, range are your output values. The x-intercept, it looks like it has an x-intercept over here, but I'm not going to assume, okay? So we would have a second x-intercept, but let's just note the one that we see in the graph. So 2, 0. Our y-intercept is 0, -2. This graph is increasing. This is x equals -2. This graph is increasing from -2 to positive infinity, and then it's decreasing from negative infinity to -2. As x approaches negative infinity, f of x approaches positive infinity. As x approaches positive infinity, f of x approaches positive infinity. As we go left, our graph goes up. As we go right, our graph goes up. Our domain, we have arrows on the end, so it's going to be all real numbers. Our range, we can go down forever. Again, we always list the least number first, and it can go up forever. The x-intercept we see is almost 2, so I'm just going to estimate that. So we'll just say 2.1, 0, and our y-intercept is going to be 0, 4. We're going to need these vertical lines. So this is x equals 1, and this is x equals -1. So the increasing part is just here in the middle. So it increases when between x being -1 and 1. And then it decreases on this side from negative infinity up to the -1. And it decreases from 1 to positive infinity. Okay, again, you're always looking at your x values to get your increasing and decreasing. So this time, as x approaches negative infinity, as we go left, our graph goes up toward positive infinity. And then as x goes to the right, as x values increase, our output decreases. And it's all about the ends, nothing in the middle here, just the ends of your graph. 7, we have a negative parabola, a parabola that turns down. I'm going to go ahead and pencil in that axis of symmetry that's going to help us with our increasing and decreasing. So that's x equals -1. Our domain, we have arrows on the end, so it can go forever left and right. Our range, it can extend down forever, but then it has a ceiling here of, this is 6, 7, 8, 9. So when y is 9 is where it is restricted. So that is your range, how far down and how far up. My x-intercept is going to be, it looks like -4, 0, as well as 2, 0. My y-intercept is 0, 8. It increases on the left side here, so from negative infinity up till x is -1, it increases. And then it decreases at the x being -1, it turns down, and it's from -1 to positive infinity. As x approaches negative infinity, f of x approaches negative infinity. It turns down. As x approaches positive infinity, f of x approaches negative infinity. So again, when you have a parabola, a quadratic function, your end behaviors are going to be the same. They both turned down. Okay, here we have an exponential function, and let's pencil in our asymptote, y equals -2. We have arrows on the end, so we have all real numbers. Our range, how far down does it go? Well, it goes down to the -2, but does not reach -2. It's not included. And then our graph extends forever up. Our x-intercept is going to be -1, 0. Our y-intercept is 0, -1. This increases nowhere. As I read from left to right and I look at my graph and I trace it, I'm going down, down, down forever. So it never increases. And what caused it to decrease? All real numbers. As x approaches negative infinity, f of x approaches positive infinity. As I go left, the graph is going up. As x increases, f of x approaches and doesn't reach, but it approaches the -2, the end behavior, going toward that -2. Domain here, so it's not all real numbers because we have some endpoints. So how far left does it go? It goes to -5, and it does include it because it's closed. And then it extends to +5, but it's not included. My range, how far up or down? Well, it's just right there at the 2. So I'm just going to put 2. The range is just 2. My x-intercept, there is none. My y-intercept is going to be 0, 2. This graph neither increases or decreases. It's just constant. It doesn't go up. It doesn't go down. And my end behavior. As x approaches negative infinity, f of x approaches, what happens? As we go left, we just remain and stay right there on the 2. As x approaches positive infinity, f of x, again, just approaches the 2, okay? So as we go left, it just remains at 2. It doesn't go up or down. In behaviors, what's happening at the ends of the graph. Excuse me, domain here. How far left do we go? We go to, that's -1, -2, -3. It's not included. And then over here, we're going to the -5. Again, it's not included. So domain, how far left, how far right? The range, how far down does it go? It goes down to -2. It is included. And then it goes all the way up until we reach here at 6. And it's not included. My x-intercepts are -1, 0. And we have 3, 0. My y-intercept looks like about -1.5. And increasing, so I'm going to put my axis of symmetry, that's x equals 1. It is increasing on the right side of the axis of symmetry, so from 1 to infinity, it goes up. And then what causes it to go down is from, oh, wait just a second, the increasing, we're going to have to change this. This is not forever up. So we're just going to have to go until we get to the 5. Oh, I'm glad I caught that. So this area from 1 to 5, this graph is going up. So let's change that. When I get in a hurry, let's not get in a hurry here. So from 1, when x is 1 to 5, 5, that's a 5, the graph is going up. And decreasing, it's decreasing from, this is -3, -3. So from -3 to +1, the graph is going down. As x approaches negative infinity, f of x approaches a particular number. So as we go left, our graph approaches 6. As x approaches positive infinity, f of x approaches 6. Our domain is not all real numbers, so how far left do we go? -5. How far right do we go? 1, 2, 3, 4, 5. That is also 5, and they are included. My range, how far down does it go? It goes down. This is 1, 2, -3. So it goes down to -3, and then it goes up till we get to +3 here. The x-intercept is -2, 0, as well as 4, 0. My y-intercept is here at 0, 2. It increases on this side, and let's draw our little axis of symmetry here. That is x equals 1 again, and so it increases from -5 until we get to 1. And then it decreases from 1 until we get to here at +5. As x approaches negative infinity, f of x approaches -3. As x approaches positive infinity, f of x approaches, so as we go toward the right, it approaches -1. And number 12, the domain. How far left do we go? We're going to -1 right here. Again, domain is our x values. And then to the right, it goes to +2, but not included. Our range, how far down does it go? To -5. And then how far up does it go? To +4, not included. Our x-intercept, maybe, let's just say, I think it's like 0.75 or 3/4. And our y-intercept is 0, -2. This graph increases. Again, it's all about the x values. So when x is -1, and we can go ahead and include that. So from -1 up until we reach the 2, it doesn't decrease at all. As x approaches negative infinity, as we go left, f of x approaches -5. As x approaches positive infinity, f of x, our output, approaches 4.